Did you know that you can use a function model to represent a real-world problem? Take a look. Joseph has a newborn baby in his family. When the baby was born, the doctor weighed the baby. And now, every time the baby goes to the doctor weighs the baby again and keeps a record of how the baby's weight changes. When the baby turned 1 year old, then the doctor showed Joseph the weight of the baby. This weight had changed since the baby was first born. In fact, it changed gradually over time. Which type of function model would be best used to show how the weight of the baby changed over time? This is the question that we want to ask. So in order to figure out which function model would be best, the first thing we have to do is think about each function model, and there are 3 of them. The first model is an exponential model. This would represent exponential growth. For example, if the baby weighed 7 pounds when it was born, an exponential model would show that it would weigh 49 pounds. Since 7 squared is 49, and 7 squared represents an exponent, that doesn't seem to make a lot of sense. It's probably not the best model to use for this example, but let's think about another one. The second type of model is a quadratic model. However, a quadratic model represents a quadratic function or a quadratic equation and has the graph of a parabola. Parabola can look like this, or it could look like this. Either way, it doesn't seem to make sense that a quadratic model would represent the baby's weight during the first year of life, given that the baby's weight would change a little bit over time. So let's think about the third model and see if that is a better option. The third option is a linear model. Now we know that a linear graph is represented through a line. It can be a line that goes upward or a line that goes down. A linear model represents a gradual change over time. So let's think about what that would mean for our baby. Let's say our baby weighed 7 pounds at birth, and then the next month he weighed 10 pounds, and the next month he weighed 12 pounds, and then his growth maybe didn't change the next month, he was still 12 pounds. But then the month after that, he weighed 13 pounds. And we could go on and on and on until his final weight was 21 pounds at 1 year old. Now you can see that this is a gradual increase. If we were going to put this in a table, draw the table here, we could say here's our pounds, and we could put months over here. So we could put 0, because he's brand new here, 1 month, 2 months, 3 months, 4 months, and finally 12 months. And we could graph this data. Let's take a look at how to do that. Here's a graph at one quadrant. Now let's go ahead and graph the points. So what we're going to say is that here is our x-coordinate and here's our y-coordinate. So our first point is going to be at 0, 7, our next point at 1, 10, our next point at 2, 12, our next point at 3, 12, then at 5, 13, and then at 12, 21. Now, while our data doesn't form a completely straight line, it is still a linear model, and we can draw a line of best fit that comes right through here like this, which is used to represent how a baby's weight changes through the first year of life.